Hi there, this is Penelope, F3128, Topic 5, Class 2, where we're going to look at graphs. And you need to remember, a graph is only a picture, so that's all we're dealing with is a graph. But first up, we've got to draw the space where we're going to put our picture. And what we do is we draw two number lines at right angles to each other, and they intersect at the point 0, 0, which we call the origin. That means now we've got an x-axis and we've got a y-axis. And we talk about this being the Cartesian plane. Every point on this Cartesian plane has a unique address, and it requires an x coordinate and a y coordinate. And what we do is we talk about the quadrants. We talk about quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That just means part of it. This idea is useful when we come to looking at trigonometry. So each point has a unique address. So 1, 2 means 1 out and 2 up. And 3, -1 means 3 out and 1 down. So you get the idea that negative in the y direction is down, and negative in the x direction is to the left. Sometimes, and again this is just a review of what we've done before, sometimes we do just need a number line rather than the quadratic equation. 1 is less than or equal to x that's less than or equal to 3. We would write as 1, 3, and it would be a closed interval, and we'd use coloured in boxes. This is an open interval, and we'd use open. This is semi-open, semi-closed. We'd use it as open and closed and closed and open. Again, we've done this before. The interval -3 to 4 includes -3 and 4, and the interval 1 to 4 doesn't there. So we'd use open circles. Now, if we're trying to graph a line, then we need to, in this case, before we know what we're doing, before we practiced at it, we can plot it. So what we do is we just choose some x values, and in this case we're told that x is from -3 through to +3. We set them up in a table, and then we go ahead and we work out the y values. So I've done that for you. I've got the x and the y values there. To find the picture, what we do is we say for each of these we find the point and then we join them up like this. So every point on the line is one that was in the previous table. Now, if we know that it's going to give us a straight line, then we can use a ruler. If it is a linear equation, then it's going to give us a line. That's why it's called a linear. So it will give us a straight line, so we can just join up the points. We can't always, but in this case, yes, we can. Here's a different one. Clearly it's not linear, it's a quadratic because it's got x to the power of 2, but we can go ahead and do the same thing. We can find the x values, choose some x values that it says in the question, find the y values that matches them, and then plot those points on a set of axes. Now this time it's not a straight line, they're not going up in equal lumps, so we need to be very careful and use our hand to just sketch it like that. If we're going to draw a graph, the important things are its shape. You've got to label where it cuts the x-axis, so label that number. You've got to label where it cuts the y-axis. Really need to label your axes as well. And you need to label the curve. So if it's something like that, it'll be y equals x squared plus da 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 da. Okay, so you must label it as well, because you might have more than one on the axis. Just a reminder, independent variables are the ones that we choose, say x, the dependent are the ones that depend on that, say y. The domain is the set of independent variables. And the range is the set of dependent variables. So here the domain is the set of the x variables and the range is the set of the y variables. If we don't have a limit on the x values, then the domain is infinite, as is the range. In this particular example, we've got some x values, -2 through to 2, and the range is all numbers greater than 1. So we'd write the range as y is an element of the set y, such that y is greater than or equal to -1. We can have some funny graphs. Now in this case we can't have x equals 0 because it's undefined. We can't have y equals 1 over 0. It doesn't work. So we've got a graph that's in 2 parts. So look out for those. We can also have a graph that's defined what we call piecewise. It's defined in pieces. So we've got a first bit, we've got a second bit, and we've got a third bit. Take note of where they begin and end. So the first one includes the beginning and the end. The second one doesn't include the beginning but includes the end. And the third part, because it's x is greater than 6, doesn't include the beginning but just goes on indefinitely. We can talk about the solutions of an equation as we did in the previous section. And these are where the curve cuts the x-axis. So in this case, the solutions of x squared plus x minus 3 equals 0 are the solutions x equals, I don't know, 1 and a bit, maybe 1 and a sixth, I don't know without working it out, but it's 1 and a little bit. Or -2 and a bit, maybe -2.5. Hard to say from the graph, but you can read them off the graph. If I were to use my calculator, I might have seen that x was approximately equal to 1.3 and x is approximately equal to -2.3. I could also find the vertex. The vertex is this bottom corner and it's going to be halfway between the two intercepts there. So the vertex, the x is going to be, so the distance between there and there, or the distance between -2.3 and 1.3 is 3.6. So my distance between them is 1.8. So that's 1.8 units from -2.3, which is x is -0.5 approximately. The same for another curve. I can find there the solutions, so I can solve it. There are the solutions there. And if my graph looks right, the solutions are x equals -2, x equals 1, and x equals 4. If my graph's good enough. If it's not good enough, then it's going to be a bit wonky. But okay, same here. We could find the solutions. I'm not sure what they actually are, but we could find the solutions as being there, there, and there. We could also use graphs to find the solution for two equations at a time. Remember, we were solving simultaneous equations before, so we could find them on a graph as well. Now, the reason that we tend not to do that is unless we've got some graph drawing software like Desmos, our graphs might not be very accurate. But if it is accurate, then we can see, for example, here 3x minus y equals 9, x plus 2y equals -4. They meet at 2, -3. So that is the solution to that. So x equals 2, y equals -3. We could do the same for this one. We could then just read off that the solution is where x equals 1 and y equals 4.